All right, so what we're going to do now is we talked about how to figure out how many sig figs you got. And now we're going to talk about, well, if you've got numbers and you're going to add them or subtract them or multiply, whatever, how do you deal with that? Okay, so let's start with the rule of addition and subtraction, okay? Two rules we're going to look at. This is the first one, okay? And whenever you're combining numbers, no matter what it is, addition, subtraction, multiplication, whatever, you always want to you need to identify the weakest link, okay? You have to identify the weakest link. Now, how do you know which one is the weakest link? Well, that's the key, okay? And I'll tell you about that, but here's why it matters, okay? So remember when we talked about precision and accuracy, and I said, well, let's suppose that you've got a target and you're going to shoot at the target, okay? Now, and we said like one gun is like, maybe one gun fires like this. Okay, we said one gun's real precise and the other one's not. But what if you couldn't tell which gun was which? All right. So what if you don't mark the holes for each gun independently? All right. You just shoot one gun first and then you pick up the second gun and you shoot it too. Okay, do you see what happened here? So if you can't tell which gun is which, all that matters is the worst gun. Okay, all that matters is the worst gun. So if we were to look here, try to calculate a precision for this, the worst gun totally dominates the situation. The really nice gun doesn't even matter. Okay, so let's take a look here at some numbers. Okay, and so I've got 123 and 1.52. Okay, now let's just blindly add them together. Let's just add them up, okay, and that's going to get us 124.52. Okay, but now let's put some units on there. Let's suppose that these are both meters. I've got two different length measurements. So I have 123 meters and I have 1.52 meters. Okay. So 123 meters, that's pretty big. Okay. And what we're saying with 123, remember, it's not 123.0 or anything like that. It's 123, which means that our precision is out here. And we're kind of really saying could be 124, could be 122. We're calling it 123. Okay. So in other words, it's kind of like saying plus or minus a full meter there. Okay. Now, 1 meter out of 123 is less than 1%. That's not too bad. Okay. But that's still a full meter of uncertainty. Now, over here with this number, 1.52, that's 2 centimeters. Okay. So if you've got something and it's fuzzy on the scale of a meter, fuzzy on the scale of a centimeter doesn't matter. It's completely obscured. Okay. It's completely obscured. And so the 123 is the weakest link. All right, that's the weakest link right there. Now, we might go, yeah, but they both have 3 sig figs. Well, that is true, but remember, a centimeter of fuzziness is inconsequential compared to a meter of fuzziness. So the way we decide which one is which is we think about this. That number is in the ones column. Okay, the 5 is in the tenths and the 2 is in the hundredths. Okay, so the ones column is the largest decimal place. So that's where we're fuzziest. Okay, that's where we've got the fuzziness. And we have to retain that level of fuzziness. So if the fuzziness is in the ones column, we retain it in the ones column. And so the way you do this in practice is You write down the whole number, 124.52, but then you say, well, really, that's 125. Okay, so we're going to round up, but we only get the digits where they end up with the ones. Okay, that's what matters right there. Okay, now let me see if I can move. Yeah, great. Okay, I'm going to move that right over there. Okay, so let's look at the next example. Get rid of my stuff here. Okay, 5.268.312. Okay, now we don't know if these are meters or if these are Gauss or if these are Furples. I made the last one up. What we look for is the weakest link. Okay, the weakest link here for this number, I'm saying that wrong. The precision for this first number falls into the hundredths, but for this one it falls into the thousandths. Okay, the hundredths is fuzzier than the thousandths. Okay, so what we're going to do, we're going to add these things up, and we get 13.572. Okay, but the fuzziness at this level right here obliterates that one. Okay, so when we get ready to write down to record or report our answer, we're going to say 13.57. Okay, now something weird just happened there. Did you see that? We actually ended up with 4 Sig Figs. All right. This number has 3 Sig Figs. This number has 4, but we said the last one doesn't really count, so it's really kind of like 3. But we increased our number of significant digits. We went from 3 to 4. Okay. Is that a problem? It's not. It's not a problem because we are looking at the column position to determine the weak link when we perform our addition or our subtraction. Okay, so with addition or subtraction, you could gain sig figs like we did here. We went to 4, or other cases you could lose sig figs. We might have gone from 3 down to 2. Okay, that can happen. All right, that can happen. So an example of that would be, well, what if we added it to 8.3? Okay, well, that's going to give us back to 3. Anyway, I'm not going to do a good job of making up an example on the fly there, but you could play around with that. You'll figure out. So we could really have our sig figs increase or decrease or remain the same. Okay, and when that happens with addition and subtraction, then that's just part of it. Okay, now let's look at the next example here. We got 1,000 minus 154.2. Okay, now let's just execute the subtraction straight away. Okay, hang on, I want to move this stuff. Sweet. Okay, all right, so let's just execute that maneuver. 845.8 is the answer. Okay, now where's our fuzziness? Okay, this is a tricky one. Okay, I'm not gonna lie, this is kind of a tricky one, and so there is a little bit of wiggle room in these things. Okay, these things can be just a little bit weird, but the fuzziness is here. It's in the ones column. Here it's in the tenths column. Okay, sorry, this is the thousandths and the tenths. Okay, so the thousandths is going to overwhelm the tenths. Okay, and so what we really need to do here is to report this number as 1,000. Okay, that's a little bit tricky. Okay, don't go and try to explain that to your third grade nieces and nephews who are just now learning about addition and subtraction. They're going to be like, but my teacher didn't say it. Okay, they're going to be very confused. All right, but what we're talking about is with a measurement. All right, so if you've got something that's measured only at 1,000, okay, then the other number it isn't going to make any difference. Okay, when might it begin to make a difference? Well, it could begin to make a difference if this was 554. Okay, because if it's 554, then I'm going to get it 445, and that rounds to 0. Okay, so I got to go to the nearest thousandth. Okay, that's I don't have any choice. I have to go to the nearest thousandth. All right. Now, all this could be different though. All bets are off if we had a decimal point right here. If we had the decimal point there, that means the ones column is significant. Okay, and then I can write 846 as my answer. Okay. It still is, the ones column is still fuzzier than the tenths column, so I don't get to keep my tenths, but I do get to retain my single digits, my ones column. Okay. All right. So that's addition and subtraction. It is the more complicated one. Okay. It's the more complicated one. Let's look at some multiplication and division. Okay. In this case, these are super easy because you just look at the number and you got to say which one has the fewer actual number of sig figs, and you use that in your answer. So let's say 50 times 6, that's 300. Okay, so this is 300 right here. Okay, I've got 1 sig fig here. I've got 2 sig figs there. Okay, and so I have to keep the number 300 just like that. Okay, that's just one significant digit to report. All right, now it doesn't even matter if we put in a whole bunch of zeros here. None of that matters because I've just got one digit here. Okay, now what if it was 50 point like that? So now I've got 2 sig figs here. Okay, and I guess looks like I got 4 there. Okay, so now what do I do? Well, this is when I would need to put like an underline here or a little tilde over this somehow to signify that that first 0 there matters. Okay, so I got to put that in that matters. All right. Now we could go what if it was 50.0? Okay. Well, now then I'm going to have to put a little dot here so everybody knows that this last 0 matters. Okay, just like that. Still, my 4 digits was 6.000. It doesn't really matter because the weakest link is still the 50. Okay, so all you have to do is identify which one is the weakest link, and then you'll be in good shape. Okay, so let me clear some stuff out here. Boom, boom. There we go. Okay. Let's look at the next one. I got 3 divided by 9, okay? So 3 divided by 9 is going to return 0.33333, repeating. Okay, so this is never going to end, okay? So, if this represented some kind of a measurement, okay, maybe a concentration, maybe I've got 3 grams of salt in 9 liters of water, okay? Maybe something like that, okay? Well, I can't specify my number as 0.3333 repeating. All right, I got to look. Here I've got 3 digits. Here I've got 2. I get to keep 2 digits. So I report my number as 0.33 grams per liter. All right. That's all I got. That's all I got. Okay. Now that could change, if we had, something like this, then I could come along here and add another digit just like that. What if we had this? What do you think? Do I get to add another 3 on there? No, I don't. I don't because I still only have 3 over here. Okay, so that's the basic there with multiplication, division, and stuff like that. Let me show you a couple of special cases to be aware of. These kinds of things can trip you up if you're not ready for them, all right? So let's look at the cube root of something. So maybe I've got a volume. All right, it's turns out to be 64 cubic meters as I've measured it, 64.00. Now, we don't know how we got that number. It doesn't even matter. But we might want to know, so if this volume were a cube, then how big would each side be? Okay. Well, the cube root of 64, that's 4 times 4 is 16 times 4 is 64. So the cube root of this thing is 4. Oops. Just kidding. Wow, that was almost a disaster. So the cube root of this thing is 4. Okay. Now 4 is just a single digit. What do I do here? I mean, I've got two numbers, right? I've got a single sig fig here. I've got 4 sig figs there. So what do I do? Okay. Well, in this case, the number 3 is a whole number. Okay. It's a whole number. It's exactly 3. It's 3 point. You can't even say it's 3.0 with an infinite number of zeros. That's not good enough. Okay, this is a whole number, 3. And a whole number has an infinite amount of precision. Okay, so automatically it is not the weakest link. All we do is we look at what we have left over. So I got 64.00. So I need 4 sig figs. I started with 4 sig figs. I need 4 sig figs in the end. So 4.000. Okay, so that becomes my number there. Okay, just like that. Okay, now let's look at the last two examples because they also could be a situation where you have a whole number. Okay, so maybe you've got 5 cups of fluid, and it turns out that there is I don't know, maybe they're not cups, maybe they're droppers. Maybe it turns out that you've got 30 milliliters in total. Okay, and you want to know, well, what's my average in each one of these? Okay, well, execute the math first. 30 divided by 5 is 6. Okay, now let's talk sig figs. Okay, again, that's a whole number. It has infinite precision. All right, it has infinite precision. So it doesn't even factor in at all. All I do is I look at the number 30. The number 30 there, 3 sig figs. I need to have 3 sig figs in my answer. So I get an average of 6.00 milliliters per eyedropper. Something like that, okay? Now, let's suppose my eyedroppers actually have 25 milliliters in them, okay? And I got 5 of them. How much is my total? Well, again, the 5 is a whole number. So 25 times 5 is 125. But I need 4 sig figs. So we slap a 0 on there just like that. Okay, so when you're doing these with addition, I mean, and that's true with addition and subtraction too. Be careful if it's a whole number, all right? If it's a whole number, it doesn't come into play. It's not in play for calculating your number of sig figs, okay? All right, well, that went a little bit longer than I thought it might, but anyway, so we're going to end. I don't know why it says end part 3. That's the end of part 2. So, anyway. Okay, so we got one more part to do.